Okay, let's look at this projectiles question. Let's use a highlighter and look at the keywords. It's launched from the edge of a boat at an angle of 80 degrees above the horizontal. Initial speed of 75, so that is u. We can ignore the height of the boat and answer to 3 significant figures. That's all we need to know. And do read the rest of the question, or pause this video anytime you want. And we do have to look at which one of these SUVAT formulas we might need that later on for part B. So, find the initial horizontal speed of the flare. So we resolve horizontally, but let's look. We know, we draw a triangle. Imagine this is the boat, but its height is negligible. So we can just treat that as ground level. From the horizontal, it's at 80 degrees, and yes, 80 degrees is steeper than this, but just so you get the idea. Now that is going at 75 meters per second, and this makes a right angle. So the horizontal, that's 75 meters per second. We should remember that that is 75 cos 80, and going horizontally, that's going to be 75 sine 80. Your chapter 5 knowledge will help with that. So obviously we're just using SOHCAHTOA there. So the horizontal, so resolving this way, we can see that that is just 75 cos 80. So that's going to equal 13.023624 dp, and it does say 3 significant figures where appropriate, so that's just going to be 13.0 meters per second. Now it says find the vertical initial vertical speed. Well, that's going to be 75, so that's going to be 75 sine 80, which is 73.9 to 3SF, and that's to 3SF. So let's have a read at B. Do pause the video whenever you need. Now let's have a look. For B part 1, the height of the boat is negligible, so we can assume it's launched at height 0. H is 0 when it's launched. Now let's resolve that vertically, and that up is positive. So we have from here u equals 75 sine 80. Now we know acceleration, that's going to work on it. So acceleration is going to be minus 9.8. And it says 200, so S is going to be 200. Now I'm going to show you this flare. It is going to flow like this, and S is equal to 200. So there could be 2 times that S would be 200 at, because it does say times with an S there, and it doesn't say highest point, so that's something to watch out for. So out of the SUVAT equations, where do we have S, U and A, and we need to find T? It's this one here. So we're going to use S equals UT plus a half AT squared. Get into the habit of writing it down. Substitute those values in. So we get 200 equals 75 sine 80 plus a half minus 9.8 t squared. Now I should have wrote that somewhere so I have a bit more space. Now we want to expand that all out and bring it onto one side to solve. So this would leave us with 4.9 t squared minus 75 sine 80 times t plus 200 equals 0. Now solve this using the quadratic formula, because you can't factorise. Solve using quadratic formula, or use your class whiz tool, calculator tool, and then you'll get two values for t, and the first t is going to be the smallest value that you get, so you should get 3.54 seconds, and the second time is going to equal 11.5 seconds to 3 significant figures. Now that should make sense. Now part 2, hence find the length of the time for which the flare remains above 200 meters. So can you see this arrow here? That's when it's going to be above 200 meters. I'm going to highlight that in purple. So you should be able to see that bit here. So that's just a tablet error. So you will just minus the 2 times, 11.5 minus 3.54. Right, that will give you the times here. And that's going to equal 8 seconds to 3SF, but to write that to 3SF we have to do that. And that's if you use the original values for T2 and T1 using this. This is rounded to 3SF here and 3SF here. But if you use original values from here, you will get this answer. So hopefully that makes sense. Okay, do you have a read of this question? Highlight the keywords. And for this one, what would I consider the keywords? The bicycle leaves the ramp at 14, so that's going to be U. 30 degrees to the horizontal at the end of a pier. So a pier is normally above water. It's modelled as a single projectile, and it splashes into the water below at a horizontal distance of 28 meters from the end of the pier. Find the time the bicycle and the stunt person spend in the air above the water. Remember, pause the video at any time. Now let's have a read of part B, and we have to be careful here, because what does it tell us? Given that the end of the ramp was 50 centimeters above the pier, so we've got to remember our units. That's 0.5, because everything is in meters. So 50 centimeters is 0.5 meters. So part B, we have to resolve vertically, and I'll use that as positive. And let's remember, we did say that direction is positive as well. So we've got to resolve vertically. This means we can use A, and if up is positive and A is acting downwards, A is going to be minus 9.8. Now we know from before, this one here, acting up, U equals 7. And from before, going to use the exact answer from here. T equals 4 over root 3 seconds. And we need to find how long, and I've misread that question. That's not the height of the pier. It says given that the end of the ramp was 50 centimeters above the pier, so this is the ramp, that's 0.5 meters, and we're trying to find this height, which is going to be S in the SUVAT equation. Okay. So do be careful with your labelling and read the questions carefully. So using what I said before, S equals UT plus a half AT squared. We just substitute the figures in. So we have 7 times 4 over root 3. We do have A, so plus a half times minus 9.8, and T is 4 over root 3, so 4 over root 3 squared equals S. And because we're resolving vertically, that makes sense, because then we will be finding, using this formula, this height from the ramp, because we're using time. So if we just solve for all this and input in the calculator correctly, we will get 28 over root 3 minus 392 over 15, which is going to give us minus 9.967525. Now that would make sense, that's minus, because if we're resolving vertically, the height from here, and I will use H, is going to be positive going upwards, but downwards it's going to be negative. Like on the XY axis, it's going to be negative Y. Now find the height of the pier given your answer the nearest tenth of a metre. Well, to the nearest tenth, so to 1 decimal place, that actually rounds up to minus 10 metres. Now the height of the pier is 0.5, so obviously we're going to say this height is actually 10, including the ramp. So it's going to be 10 meters minus the height of the ramp, which is 0.5, so it's going to be 0.5 meters, which is the height, do state this, the height of the pier. Lots of little steps there. It is doable, so do pause the video, go back 5 minutes or 7 minutes and give this question a go again and see if you can do it from scratch. This is how you're going to get really good at this skill. It is doable. So you can use the constant acceleration formula for a projectile moving in a vertical plane. So read the question. A particle is projected from a point O with speed v meter per second at an angle of elevation theta, where tan theta equals 4 over 3. The point O is 42.5 above the horizontal plane, and the particle strikes the plane 5 seconds after it's projected. Lots of words there. Show that v equals 20. We've got to find the distance between O and A. So we just start this with a diagram. This is because the point O is 42.5 meters above the horizontal plane. Now we can see V, and it's an angle theta. Perfect. And then obviously the projectile is going to follow this motion due to acceleration and gravity, or the acceleration of gravity. A is the distance A. Now because we know tan theta equals 4 over 3, and we want to resolve vertically and horizontally. We'll resolve horizontally to find this distance A, and we will use the vertical, which is going to be V sine theta. Now find the values of sine theta and cos theta first by labelling a triangle where tan theta equals 4 over 3. That is the opposite equals 4 and the adjacent equals 3. So what does that mean? I'll draw it here. That's theta in this question. Opposite is 4, adjacent is 3. It's a 3-4 triangle. We use Pythagoras. 3 squared plus 4 squared equals 25. Square root of that, that is the length of 5. So sine theta, which is opposite over hypotenuse, is going to be 4 over 5. And cos theta, which is adjacent over hypotenuse, is going to be 3 over 5. And that's just the same thing explained again, and we're writing that down. Now resolving vertically using the information given, taking upwards as positive, so that's upwards as positive. The particle strikes the plane 5 seconds after it's projected, so the ball will be 42.5 meters lower after 5 seconds. So because we're starting the plane at O, so where it lands, this means S is going to be minus 42.5. So that means U is going to equal V sine theta, because we're resolving vertically. So V equals, we don't know, because do not use this V. We're talking about the velocity in the question. A equals minus 9.8 because we're resolving upwards, and we know the time is 5 seconds from the question. It strikes the plane after it's projected. We're using this to that equation, sub in the values that we have, calculate terms using sine theta equals 4 over 5, so you'll get V, and that 4 over 5 times 5 will cancel out, so we'll get 4V. Rearrange, and that proves V equals 20. And hopefully you can see that is doable, but there's just many steps. Lots of steps, but we can get this. Find the distance between O and A. So I believe it's good to write this down. Distance equals speed times time. Right, so horizontal distance equals this. So horizontal distance is going to equal the horizontal speed when using, because we're resolving horizontally, times 5, because that's the time. We know cos theta is 3 over 5, so substitute that in. So the horizontal distance is going to be 60 meters. Now, B does say we want to find a distance between O and A, so that's the horizontal distance. But we need to use, we create a right angle triangle here, so we use Pythagoras theorem. 74 meters to two significant figures. Hopefully that helps. And this is a problem where it's got multiple steps and how you can be thrown off just because the point O is above ground level.